spilling back into the combustion chamber of the furnace. And this is how we can tell that we have CO spillage back into the furnace. Here you can see that your stack temp is still in range. Your CO is still below the threshold of 99 parts per million, and your O2 is low. When you turn your gas down and your O2 still is low, but your CO is not high, and you have draft. But we have an issue. Why is our O2 not where it needs to be? This is an indication that we may have a possible restriction in our flue, and we may have gas spilling back into the combustion chamber of the furnace. And this is how we can tell that we have CO spillage back into the furnace. Come over to here, and we're spilling gas back into the furnace. We're over that threshold of where we should be, and eventually our high limit safety is going to trip out on our rollout sensor because that's going to get super hot. But when we correct the actual blockage in the flue, we'll see what happens. So you can see in here, just after a minute of clearing the blockage, our O2 has come up and our CO has come down. Our stack temp has gone up, our draft has gotten better, but we're not spilling back in anymore. We're at that 139, 140 mark, and it's still cooling down. We've only had the flue unblocked for about a minute. This is how we test for gas spillage. So we put a probe inside the burner chamber. I utilize this little hole right here, and it's just sitting right about here, and we'll show you where it's sitting. But just sitting right in front of this grate, we were spilling CO, and we could tell off of temperature. Just because these numbers were saying that we didn't have CO high levels in the flue doesn't mean we don't have CO spilling back. The reason why our CO wasn't spiking super high because it's spilling back to the burners, and we had a partial blockage, and we were still able to maintain combustion. But this is a safe, unsafe environment where the CO is spilling out of the equipment. So if you watch, we're going to recreate our bird's nest or something blocking the flue where it still allows air to flow. So we're blocking that flue off, and you're going to watch, look how quick that temperature climbs. That's CO spilling because that heat from the CO is spilling back into the burner chamber. And I'll show you where I have this temperature probe set up at, but you can see our O2 is still showing okay. It's going to slowly come down, but our CO is still at 20 parts per million, 21, and we never hit that threshold of where we are unsafe. But this right here is technically unsafe because we have CO spilling back into here. Let's see how quickly that temperature comes down when clearing that restriction. I'll show you where we have this set up. Take this door off. And I just have the probe sitting right there. It was sitting a little bit higher, but I moved it down. It was sitting right about there. So you see where that probe is sitting right there? And we were reading over 140. That means we had CO backing up back into here. Now, so you can see that this test does not work unless you have this door on. I'll show you. All these tests need to be done as if we were operating under normal conditions. So this door needs to be on in order for this to work properly. See how that temp's way down now? But we have CO spilling. I bet you if I stuck the combustion analyzer in here, we would have a ton of CO spilling into this space. Right now it's nauseating for me because it's so much CO coming back into here. And I'll show you that. This is another reason why plugging these holes is super important. I have CO spilling out of here right now because I have a partial blockage. There's still CO escaping out of here a lot. Through this, I have a pretty large opening, but I have CO pouring out of here now. So it's important to plug this. Use the fire caulk, put it on your aluminum tape, stick it on there, it'll make a molded plug. So if a bird's nest or something blocks the flue, or the flue cap pushes down, it won't spill back out of there into the space, and it'll spill out into here, but hopefully the high limit or the flame rollout trips it out. So as you can see now, we have no CO in this compartment. I have the combustion analyzer running. I have it pointed down inside that compartment. Our burner cabinet temperature still starting to come back up. I just put the door back on. I don't have any more CO spilling out of this hole because I have the restriction cleared. Let's put a restriction on there and see what happens. So I put a partial restriction on there. Now we have CO spilling out of here. There's still CO coming out up there. It's still moving, but if we look on here, we're already climbing up pretty quickly in the burner compartment for temperature. But if you look right here, we've already gone up to 5 parts per million of CO. That is an indication that we are spilling back into this cabinet. And we were able to figure that out with just off of temperature. As this gets higher and we're spilling more gas in, it's going to get higher on here. The plate moved and we'll move it back. So as you can see, we're still able to maintain combustion. We have enough draft in this flue with that partial restriction, but we're backing CO up at. Now you see how that temp's climbing up higher. Look at what our CO is doing. Our CO is going up. We are spilling back into here, which is going to be unsafe because that CO is eventually going to find its way. If this is in an attic, it's going to find its way down below. It can find its way into the burner compartment because, heaven forbid, you have a leak on your return. You're going to suck that CO back in and you're going to dump it into the house. So in this instance, I could go over to that supply and I could probably measure some CO, and that's off of the spillage coming in here. Because we're spilling CO into there and we can see that in the temperature. And as this runs longer, we're going to be spilling more CO back into there. And we're pumping this into the house now. Now what's going to happen if I create a full restriction? In theory, this should shut off. Ooh, that's hot. In theory, this should shut off from not having any draft, but it's going to take a while. But our CO is climbing in that burner compartment, and this thing is still running, even with a restriction. And we're dumping more heat into here. And you see how that cabinet's still climbing more CO? This is unsafe. This is why the spillage test needs to be performed. And we don't have a good draft. All of it's being escaped right here. Let's see if we plug this thing up 100%. Well, eventually it's going to spill out of all these little spots here. It's going to find its way to come out. Pull the blockage off. Put our draft back in, see what happens. So we just tripped the actual flame roll out. I had to reset it because the flames rolled out because there wasn't enough oxygen to burn. So it's recycling right now. So we relit. Let's do 100% blockage on this. And we just stripped out on the pressure switch. That's 100% blockage. So you can have a partial restriction and it will still operate. And it may look like it's operating safe, but we were spilling CO.
If you like this video or any of the other videos, hit that like button, subscribe, leave a comment, and as usual, happy HVACing.